Okay, so this is a quick review of the paper for day 9 of the stats program. So I'm just going to go through and explain what each question is asking you to do. I'm not going to go through all the working, all the details. I'll leave that up to you guys to let me know through the survey when you've finished the paper, or also through email if you email me and ask me for specific videos that you want, the ones that you're not sure about. Cool, so for question 1, you've got these two fair dice, which means they're six-sided, numbered 1 to 6, and have a 1/6 chance of each coming up. And the question here is they're asking you whether these two events are independent. So you need to know what that means. If two events are independent, then the probability of A times the probability of B equals the probability of A and B. So you're going to have to find a way to work out the probability of her getting a total of 5, which means there's 36 outcomes, because there's 6 sides on each dice, and how many of those have a total of 5. Again, there's another event here. You've got to work out the probability of 1 being low, 1 being high. Just remember that could be the first one being low, the second one being high, or the first one being high and the second one being low. So work out how many ways you can get that out of 36, and then you want to look at how many ways you can get both. And then check that rule, see if it applies for part 1. Part 2, question 2, is a combinations question. You're looking at 3 different houses being selected at random from the 12. And you've got 2 groups, houses that are greater than 14, so 16, 18, 20, 22 and 24, and ones that are less than that. You're trying to work out the probability of at least 2. So there's a few ways that you could do this. The assessment schedule looks a bit confusing, but I guess to do a probability from a combinations question basically involves setting up a fraction, and on the denominator of the fraction is all the ways that you could choose the 3 houses from the 12, so 12C3. And the numerator is all the ways that you could choose the houses that you want to meet this criteria, which is at least 2 of them being delivered to houses with greater than 14. So you've got 2 partitions there, at least 2, or you could have all 3 being undelivered. So if you work out how many ways you can select that, add them together, that's the total number of combinations of having at least 2, and then divide that by 12 C3, you'll get your probability. Cool, for question 3, it's a normal distribution question. These buildings are classified as tall, medium and short. Part 1's pretty straightforward. You're going to work out the probability of it being greater than 70 using a mean of 50, a standard deviation of 16, and a normal distribution. Part 2, the rest of the buildings are classified in a way that it's a 2-to-1 ratio of medium buildings to short ones. So whatever you work out for part 1, take that away from 100%, or take it away from 1 to work out what's left over for the medium and short, and then divide it into 3 parts. 2 of those parts will be mediums and 1 of those parts will be short. So you'll get a percentage or a decimal that matches with the shorts in terms of the probability for the buildings. Then you're going to have to use an inverse normal approach to find the z-score that goes with it. Make sure the z-score is negative because it's going to be below the mean, and then use a formula to work backwards to find out what the height that is that matches to that one there. For question 4, we've got 1 student and 5 having blue eyes. It's a 20% chance. It's a binomial question here. We've got n students, but we don't know how many students there are. We know that if for all these n students, that none of them having blue eyes is less than 0.01. So the probability of not having a blue eyes is 0.8, because the probability of having blue eyes is 0.2. And then you're trying to work out, so 0.8 to the power of n. So how many students, will I multiply 0.8 by itself? And that's got to come out to be less than 0.01. So you can use logs to solve that and work out what that value of n is. Just make sure that you use a whole number and that you take into account the fact that you want whatever n is, it to be less, when you evaluate it, for it to be less than 0.001. That might help you in terms of your rounding. Just whatever you get for your n value, go back and check that when you put it in there, it does actually come out to be less than 0.001. For part 2, this is going to be an approximation, because it's still binomial, this whole question, but given that you guys don't have any other way to do it apart from using the tables and the formulas, working out fewer than 33, which would be 32, 31, 30, 29, all the way under 0, take you a very, very long time. So for practical reasons, you can use the approximation to speed that process up, using a continuity correction of 32.5, because you want it to be less than 33. That's what fewer means. Okay, and then on to question 5. John playing games of squash, how exciting. Talks about him winning the first game, and then if he wins the first game, the probability of winning the second game is different at 0.6. So that kind of tells you it's going to be a probability tree. So you're going to set up your tree, fill out all the values using the information they've told you here, and then this last sentence here tells you what they actually want you to solve for the question, which is a conditional probability. So given that he wins the second game, find the probability that he won his first game. So you have to remind yourself that you're looking at the probability of A and B over the probability of B for that one. So the probability of B is the condition. The condition is that he wins the second game. So the probability of him winning the second game is on the denominator of that fraction. On the numerator of the fraction is him winning his second game and winning his first game. So both of those events happening. And then divide it through to get your answer for part A. Part B is not actually bad. It's really lots of words, but it's not really that bad. Jack's got 15 cards, 10 of them are robots. Yeah, Emma's got a pack of cards. You don't know how many there are. You know that there's 7 robots and x minus 3 of the airplane. So in total, she's got 7 plus x minus 3 cards. To get the probability that both of their cards have a picture of robots on it, you'd take 10 over 15 and multiply it by 7 over 7 plus x minus 3, so 4 plus x. And that's going to equal 7/18. So that just becomes algebra. Yeah, you set up an equation, rearrange it, solve it in terms of x for part B. For question 6, cumulative frequency, all good. It's already done for you. Just check that second row. Is it cumulative frequency or is it frequency? Sometimes it might give you frequency but still ask you to draw cumulative frequency graphs. You'd have to add the row yourself where you do the cumulative frequencies. The main thing for part 1 is to remember that when you plot cumulative frequency, you use the end of the group as your x value, and make sure, of course, that you label your x and your y axes as well. For part 2, just be careful. It says 64 way more, but cumulative frequency is always less than that value, so you'd have to take 64 away from 144. And so you're looking at 80 people weighing up to or including that weight. And then use a horizontal line on your graph to then find which value of the weight matches that. And for part 2, working out the mean and standard deviation, the only trick thing here is not the midpoints, which you should be familiar with, but the fact that this is cumulative frequency here first. So you'd have to add a row and turn it into frequencies. So for example, that would be 0, that would be 12, but this here would be 22 in that group. So you have to make sure you've got the individual group frequencies first before you work out your mean and standard deviation. For question 7, which is... think about those dogs. The first question is a combinations question because it's asking you for selections, and you've got this criteria that you're selecting 7 dogs in total, but you could have at least 1 spaniel, at least 2 retrievers, and at least 3 poodles. So you have to set up your different ways of doing that. So, for example, it could be 1 spaniel, it could be 3 retrievers and 3 poodles, and that would meet the criteria. So make a list of all the ways that you can find these 7 dogs that doesn't meet that criteria, and then for each of those ways, use your combinations and multiply them to get the total, and then add those up at the end. For part 2 and 3, they're asking you now to place them in a line, and you're looking at arranging them, and you're down to only these 7 dogs here. So here you want the spaniels to stand together and the retrievers to stand together, and the poodles can go wherever. So you're going to make a group of spaniels and a group of retrievers, and then put the 3 poodles around that. It makes you 5 things that you're arranging, so it's 5 factorial. But then within each of the groups of spaniels and retrievers, you can arrange those 2 factorial ways. So it's going to be 5 factorial times 2 factorial times 2 factorial. Okay, and for the last one, we don't want the poodles to stand next to each other. So you first of all start off with the spaniels and the retrievers, and they can go anywhere. So that's 4 factorial ways of arranging them. And then what you want to do with the poodles is you want them to go between them. And you think, okay, well, how many gaps are there between them? Possibly there's 5 gaps between those 4 dogs. And so when you're thinking about, so normally when we do these permutation questions, you've got the same number of spaces to fill as you do objects, right? In this case here, we've got 5 gaps, but just 3 poodles. So you kind of put it to yourself this way. So the first poodle has got 5 spaces it can go into. The next poodle has 4, the next poodle has 3. So it's going to be 4 factorial times 5 times 4 times 3.